Hello there guys, and welcome back to another epic Inexorable maths video. I'm wearing sunglasses today because it is unbelievably bright outside, and I don't know if you can tell, you can maybe even see it through the reflection of my sunglasses, but it is like there is a massive window right in front of me and it is genuinely shocking. So I'm just wearing sunglasses. Yeah, just why not, you know. Also, I just felt cool because maths is cool, so, you know, there's that as well. Anyways, guys, let's get straight into this video. We want to factorize polynomials using the factor theorem. That's the point of this video. And actually, this is a really, really useful thing that we can do because it lets us factorize things that are not quadratics, do not clearly just have, you know, factors in them that can be really easily factored out. So, for example, you can factorize cubics. You technically do know how to factorize cubics, but they're just ones where it's like, I don't know, I'm going to make up a cubic, ax cubed plus bx squared plus cx. Okay, well, that's technically a cubic, but you can just factor out an x and turn it into a quadratic, and then it's just not really that bad. And you can do it because then you can factorize the quadratic just using, you know, whatever method that you want. That's not what we're doing, because look, this is a cubic. This is what we've got. We've got a cubic right here in this question that we're about to do. But hold on, that 8 does not have a factor of nx in it. So you can't do what I just said. So this is where the factor theorem comes in, and so does polynomial long division, because they're really, really, really helpful tools in order to factorize a diversity of polynomials that you won't have before. So this is really, really powerful because, you know, polynomials appear everywhere. So it's quite nice to be able to factorize as many of them as possible. Now, this won't let you factorize any polynomial because you need to know, basically, depending on how many times you need to factor it. So if it's a cubic, it's going to need to be split into 3 different factors. You are going to need as many roots as there are factors in order to factorize this thing. So for instance, if this is for this one here, we will probably only need to use polynomial long division 1 time, because then we can turn it into a quadratic and then we can start doing quadratic methods. But let's say that you had like a quintic or something, you would need to use polynomial long division multiple times, and you would need to know multiple factors or multiple roots, which is difficult sometimes because you have to guess them. You basically have to guess the roots in A-level maths. So let's dive into this thing. I've talked long enough. Okay, how do we do this? Well, 2x cubed, 3x squared, minus 18x plus 8. That's what we're looking at. We want to use the factor theorem. How do you use the factor theorem? Well, the factor theorem states that if our goal here is to find a factor that we can do polynomial long division on without getting any remainder, so we're looking for some like x, we're looking for some x minus p, where, you know, p is just like a constant, it's just a number that we're looking for. We want to be able to divide it by that. Factor theorem says that if this is a factor, of our f of x, which is just this guy here, but I won't write that, then f of p is 0. Okay, and vice versa. It goes backwards as well. So if f of p is 0, then x minus p is a factor. So if we can find some f of p equals 0, then we know that x minus p is a factor, and we can do polynomial long division on it. So this is what they want you to do, basically. They want you to guess numbers to see which ones work. Now, I think I've said this in a previous video as well, but they will never ask you to guess silly numbers. They will never ask you to guess the number 701. They're going to ask you to guess 1, 2, 3, 4, 5, or minus 1, minus 2, minus 3, minus 4, minus 5. That is really the maximum that they'll do. They really don't go past 5 or minus 5 on either end of those things. So you can bet it's going to be a pretty easy number. The first one I would always try is the number 1 and then minus 1. So let's try this thing with 1. Let's see what happens. So if we say, just to be clear what we're doing here, if we let this whole thing equal 0, we need to find values of x which satisfy this equation, and then we'll know the factors. If we substitute in the number 1, we get, well, this just stays as a 2, this is a 3, this is a minus 18, and this is an 8. I'm not even going to work that out. This is clearly not going to be the answer, just looking at it. Okay, try minus 1. That's minus 2 plus 3 plus 18 plus 8. Same thing. It's definitely not right. Don't even add those things up. It's just definitely not right. Okay, the next number you should probably try is the number 2. So this is 2 times 2 cubed. That's 16. Plus 3 times 2 squared. That is 12. So 16 plus 12. Minus, okay, 18 times 2, that's minus 36, plus 8. Hold on, okay, hold on. We're getting somewhere. Huh, what's going on right here? Okay then. 16 plus 8, that's 24, I will do these two first. That's 24. Plus 12, that's 36. 36 minus 36 is 0. So look at that. I probably did that in a more complicated way than needed. 16 plus 12, that gives you 24. Take away 36 gives you minus 8. Plus 8, that gives you 0. That's basically what I said. It's equal to 0. It's right. Yay. So 2 is a factor of Rf of x. 2 is a root of Rf of x, which means that x minus 2 is a factor using the factor theorem. That's literally what the factor theorem states. Boom. So what can we do, guys? We can do polynomial long division using x minus 2. And we know that there will not be a remainder because it is truly a factor. When you have factors, there are no remainders. So we can just do polynomial long division on this guy. 3x squared minus 18x plus 8. Boom. Okay, let's go. So 2x cubed divided by x, that gives us 2x squared. Minus 2x squared times x, that's 2x cubed. Minus 4x squared. I've got about 5 videos on polynomial long division, guys, by the way, if you want to go and revise that if you're unsure about this stuff. But we should be happy with this by now. 3x squared minus 4x squared. That's going to give us plus 7x squared. Minus 18x plus 8. 7x squared divided by x is plus 7x minus 7x squared minus 14x. Take those away. That's a 0 there. Minus 18 minus 14 is going to be minus 4x plus 8 minus 4x divided by x is minus 4. And then we come down here again. Minus 4 times x minus 2 minus, that's minus 4x. And minus 4 times minus 2 is positive 8. Take those away. That's 0. 8 minus 8, that's 0. Happy days. Zeros, remainder, no remainders. Brilliant, amazing. So for convenience, I'm going to come back up here. We just worked out, this is literally what we just did. We just said that 2x cubed plus 3x squared minus 18x plus 8 divided by x minus 2, that is identical to 2x squared plus 7x minus 4. We just worked that out. That in and of itself implies that if we multiply the left and the right side of the equation by x minus 2, we then get that 2x cubed plus 3x squared minus 18x plus 8 is identical to x minus 2 times 2x squared plus 7x minus 4. We just worked that out. So that's factorized to an extent because we've now shown that this was the original question, factorize 2x cubed plus 3x squared minus 18x plus 8. Well, we've just simplified this thing. We've just taken out a factor of an x minus 2 out. Brilliant, amazing, fantastic, fantabulous. I love it. But we still have a quadratic that needs to be factorized. 2x squared plus 7x minus 4. You know, what do we do? How do we factorize this thing? Well, we can use any of our normal methods, or we could use polynomial long division again. And normally I would recommend not doing polynomial long division again because it's typically takes a lot longer than normal. So what we will do is we will use the method where you say 2x squared plus 7x minus 4. This is a method that I used in one video about factorizing quadratics. If I remember to do this, I will put it on a little, I'll put it in the description or a little pop-up thing that's going to come up right now. taking you back to it. I believe it's factorising quadratic equations in the form ax squared plus bx plus c, where a is not equal to 1. So the way that we do this is we multiply the first number, the a term, and the c term. This is just revision for quadratics. That gives us -8. So we're looking for two numbers that times to make -8 and add to make 7. Okay, what numbers could those be, guys? Okay, well, times to make -8. Okay, what about, like, I don't know, 8 and -1? Okay, those two times to make -8. Okay, adds to make 7, 8 and -1. Oh, look at that. They also add to make 7. So the answers are 8 and -1. And then what we do to our quadratic is we rewrite this. So 2x squared, I will say plus 8x minus 1x, which is just x, minus 4. So basically, this was a 7, right? 8x minus 8, 8x minus x, that used to be 7x. I rewrote it as 8x minus x. Why did I do that? Because these are our numbers. These are our numbers. 8 and -1. So this is 8 and -1, but I've written them with x's in front. The reason why I've done this is because now what we're going to do is we're going to try and factorise this thing. So, okay, just the first two terms, literally just these two terms here. That's going to give us, well, okay, we can factor out a 2x. Then gives us x plus 4. And then what we do is we do an x plus 4 over here. And we try and then factorise this guy, knowing that one of the brackets is x minus 4. So, okay, it's just -1. -1 times x, -1 times 4. And then what we then do is we factorise this whole thing. And we end up with x plus 4 and 2x minus 1. If that didn't make any sense to you guys, do not worry about it too much. You can use the quadratic formula or any of the other methods that you use. It's just about factorising quadratic equations. So then what I will do is I'm going to come back over here. And the x minus 2 was already there. And then the quadratic bit, we just figured out that is x plus 4 times, what was it, 2x minus 1. 2x minus 1, just like that. And this is the whole thing. This is the answer. This is the factorized version of the cubic equation, or the expression 2x cubed plus 3x squared minus 18x plus 8. We just fully factorized it, fully. So it's actually this thing here in the square brackets. If you expanded all of this out using FOIL twice, you would end up getting back to the cubic equation 2x cubed plus 3x squared minus 18x plus 8. And I think that's absolutely brilliant. Which means that we now know the roots of these equations as well. We also know that f of minus 4 is a root of f of x. And we also know that f of 1/2 is a root of f of x as well, using the factor theorem backwards, because we know that x plus 4 is a factor, which means f of minus 4 must be a root. We also know that 2x minus 1 is a factor, which means that x being equal to 1/2 must also be a root. Okay, so that is the factor theorem there for you guys, solving polynomial equations using polynomial long division, using so much crazy stuff. If you enjoyed this video, I highly appreciate it. Thank you guys so much for watching. Share this with your friends and family. See you in the next video. Cheers.